Hi everybody, welcome to our first video on thermodynamics. We're going to introduce some of the basic topics that we're going to get to during the course of the thermodynamics unit in this first, hopefully relatively short video. So let's start by introducing some thermodynamics. Thermodynamics is really about the concept of energy. And if you're going to understand energy, which actually I think is kind of hard to understand, I think energy is one of those things we sort of know it when we see it, but it's really hard to define. If you ask your physics teacher what energy is, he or she might tell you that it has something to do with the ability to do work. Okay, that sounds pretty good, but then my next question is going to be, what's work? And a lot of people will say that work is a form of transferring or transforming energy, and all of a sudden we're just back to where we started. So instead of trying to define energy, which I think is really hard to do, let's try to describe energy. Because throughout the course of thermodynamics, we're really going to be talking about descriptions related to energy. So if we're going to describe energy, let's try to come up with a list of types of energy. Now, different people might come up with different ways to categorize energy. I've come up here with a list of 6. Your physics textbook might come up with a list of 7 or 8, but I think these 6 are going to work pretty well for us. There's mechanical energy. Again, this is going to be the stuff you're learning about in physics. The kinetic energy that's associated with that moving block as it comes down the inclined plane, or the potential energy of the block resting at the top of the inclined plane. Then we have electrical energy. This is the energy associated with charges, with positive charges and negative charges, and having them separated from one another. We know that positive and negative attract each other, so there's some force, some energy associated with that attraction. That's electrical energy. Then we have radiant energy. Think about light. Think about the light that's coming out of a flashlight, or the light that's coming down to us from the sun. That would be radiant energy. Then there's thermal energy. This is the energy that we're going to associate with heat, or the exchange of heat. And sometimes this goes back to thinking about the concept of temperature. The temperature that something has tells us something about the amount of thermal energy it might have. Then, as we get closer to the chemistry stuff that we're going to be interested in, we have nuclear energy. And the first concept that should come to mind when you think about nuclear energy is going to be radioactivity and radioactive decay as those neutrons start to transform and come out of the nucleus. We're talking about some radioactivity and nuclear energy. And then, of course, there's chemical energy. This is the energy associated with chemical transformations. When one kind of compound turns into another kind of compound, that's a chemical transformation, and that's a chemical energy transformation. Now, here's a couple of examples of energy transformations, or something that has something to do with energy transformations that you have some everyday understanding of. Let's take, for example, these ice cubes here. We know that there's an energy transformation when we go from, say, liquid ice or solid ice, or in the way I've written this equation, if we go from solid ice to liquid water. That transformation involved energy. Now, in sophomore chemistry, you learned a little bit about energy transformation when it comes to the thermal aspect of chemistry transformations. You learned about enthalpy. Now, this reaction here, going from solid ice to liquid water, there's heat being given or lost during that transformation. So, think about it for a moment. Is going from solid ice to liquid water, do you remember? Is that endothermic or is it exothermic? Think about that for a second. Here's another transformation that you might be familiar with. This is combustion. Here's a gas burner that's doing its thing. Now, gas burners usually operate with maybe propane gas, but if it's natural gas, then it might be using methane. You've probably heard a lot about natural gas in the news, and natural gas is mostly made out of methane. So here's the combustion of methane. And combustion reactions also have a heat exchange. Do you remember? Are combustion reactions endothermic or exothermic? So we need to talk about energy transformation. And in class, we're going to spend some time talking about energy transformations. And in more particular, we're going to talk about how one kind of energy can be transformed into another kind of energy. And the other thing we're going to spend a lot of time in this unit talking about is what makes one kind of energy transformation possible, and what makes other possible energy transformations actually impossible. For example, you know that ice can melt, but are there specific conditions we need to have in place to make ice melt? If you think about it for a second, I think you already know the answer to that. Or how about the combustion of methane? Are there particular conditions we need to have for our system of methane to be able to combust? Now, it turns out the answer to these questions has a lot to do with the concept of entropy. And as we get into the unit, we're going to spend a lot of time talking about this idea of entropy. But this is just to set things up. Keep in mind that we're going to be talking about energy transformations and all these different types of energy, and we're going to start to learn how to quantify these energy transformation possibilities.